So here we have combined variation, where we have more than one variable this depends on, and so we're still just going to look for the keywords like varies inversely or varies directly. Another one you'll see sometimes they say jointly, so same as directly, but they're saying it depends on more than one thing. So inversely means divide. So this says the max weight, so I think we'll use W for weight. The max weight a beam can hold varies inversely. So I know the next thing, whatever it varies inversely with, inversely means divided by. So inversely with the length, we'll call the length L. And then jointly, so it means directly but compared to more than one thing, with the width, which we'll call W, and the square of the height. So we'll call the height H, but notice it says the square of the height. So H squared, not just H. All right, so what will that look like? W varies. There's always a constant in there, right? Inversely with the length, so we're going to divide by length, and then jointly with the width and the square of the height. So multiply by these two, divide by the one that says inversely. So that whole beginning part was just to get us so we could turn that whole sentence into the form of an equation. All right, then they'll give us an example number, so some actual numbers that work together. That way we can figure out what K is. Because remember, K is a constant. We don't know what it is until they give us a real-life example here. We can figure out what K is. So they say a beam that's 5 inches wide. So we'll put that in for W, little w. I guess big W I used as weight. Be careful about capital and little letters if you can tell them different. If you can't, then use a different letter or something, but either way. All right, so we're gonna fill in. So we know the weight is 5, or the width is 5, and it's 2 inches high. And notice that was H, so it's 2 squared, and 10 feet long. And that could hold a maximum weight of 8 tons. And so now I can use this to figure out what K is. So to get rid of the denominator of 10, I'll multiply both sides by 10. So I get 80 equals 5 times 2 squared, which is 4, so that's 20. 5 times 4. And divide both sides, so it looks like K is 4. So now up here, I actually have a workable equation instead of a theoretical equation where I don't know what K is. I know it's 4 times the width times the height squared divided by the length. And picture even 2 wides divided by the length. If this beam gets longer, right, it kind of sag in the middle, it's less strong. But if it's wider or taller, then it'll be more strong because it's a thicker beam. All right, so now they're going to ask us a question. So notice the example one values are just so that you can figure out what K is. And now they want to know what's the max weight a 6-inch wide, 2-inch high, 24-foot long beam can hold. And so now that we have this equation that actually works, we can plug those numbers in. So the width is 6, the height is 2 again, and the length is 24. So 4 times 6 is 24 times 4 on the top because the 2 squared divided by 24. The 24's cancel, or you can multiply and then divide, doesn't make a difference. So it looks like I get a maximum weight of 4, and then if we look at our units from earlier, the max weight was measured in tons, so 4 tons. That kind of makes sense. It was a similarly sized beam, but it was a lot longer than the 10-foot one that they gave us for their example. So they give you an example so you can figure out what K is, and then once you have the equation, you can use it no matter what question they ask.